Hi, so far we have studied about how to calculate the moles from the concentration, how to calculate the gas volumes. Now we are going to see the most interesting part, most interesting application of mole calculation, which is stoichiometric calculations. Now, stoichiometric calculations means, let's say I have 5 gram of carbon, okay, or let's say 6 gram. Okay, 6 gram of carbon I have. So I'm burning this carbon in presence of oxygen. It's going to form carbon dioxide. So how many grams of carbon dioxide is going to produce? So this calculation I can do from by using the mole concept. Let's see, it's a very interesting one. The video is going to be very interesting. So let's start with the equation, chemical equation. So here is the equation I have written. Hold on, let me just make it a little enlarge. Yes, so this is one atom of carbon is reacting with one molecule of oxygen to form one carbon dioxide molecule, CO2 molecule. Okay, now here is the molecular view also. Now I'm multiplying. This equation says that one atom of carbon, one molecule of oxygen is reacting to form one molecule of carbon dioxide. I'm multiplying all with 6.022 and 10 to the power 23. So that means I can write here 1 mole of carbon is reacting with 1 mole of oxygen to form 1 mole of carbon dioxide, right? Let's convert this mole into gram. So 1 mole means 1 mole of carbon means 12 gram. The atomic weight of carbon is 12, so 12 gram. 1 mole of oxygen will be equals to 32 gram. The MR of oxygen is 32, and 1 mole of carbon dioxide is 44. How 44? So carbon is 12 plus 2 into 16, so 32 plus 12 equals to 44. Okay, so 44 gram. Now from the equation only I can see 12 gram of oxygen is able to form 44 gram of carbon dioxide. Now this ratio is fixed, this ratio is constant, you cannot change this ratio. Means 1 mole of carbon is going to form 1 mole of carbon dioxide only. It's not going to form 0.1 mole or any other um, moles of carbon dioxide. So that means 12 gram can form 44 gram only. Now if these ratios are fixed, then 6 gram can form 22 gram of carbon dioxide, very simply. Now if I'm saying any gram over here, any gram of carbon dioxide, so let's say 100 gram of carbon I have. So how many gram of carbon dioxide I'm going to get? So as the ratio 12 ratio 44 is fixed, so it will be 44 into 100 divided by 12, right? So then only I'm going to get the amount of carbon dioxide. So if you do it in the calculator, you're going to get the answer. So I'm getting 366.67 gram. Okay, so this is how I'll be able to calculate any stoichiometric equations, any calculations. Let's see one question from past paper. Okay, here's a question from 2021 October November series. Now let's solve this question. Question is saying equation from the reaction zinc carbonate. Okay, so we need to give the state symbol. This is not a part of our discussion, but still we can do it. Aqueous over here, aqueous over here, liquid over here, and gas over here, right? Okay, let's start this. Calculate the mass of 1 mole of zinc carbonate. We know the formula. Remember always that triangle one we have learned: mass over mole times mr. So what I wanted to find, mass. So mass will be equals to mole times MR. Now what is mole? What is MR? MR, I need to find it out. MR of zinc carbonate will be equals to, the mass of zinc is 65 plus mass of carbon is 12 plus mass of oxygen is 16 into 3. So 16 into 3, which will be giving all together 125. Okay, so 125 gram, 1 mole. I'll put 1 into 125. I hope it is clear. Okay, let's move for the next. Calculate the number of moles of zinc carbonate reacting. Now it's saying reacting. Reacting means how many grams of zinc carbonate is reacting. You have to figure it out. So 2.5 grams. So again, I have to calculate mole. So mole is equals to mass divided by molar mass. So mass is 2.5 gram divided by molar mass is 125. We put it in the calculator, we are going to get 0.02 moles. Okay, now determine the number of moles of HNO3 reacting. So here is my stoichiometric calculations. Understand how we are going to do it. So we have to look at the equation. Look at the equation. Equation says zinc carbonate ZnCO3 plus 2 HNO3. Okay, so that means 1 mole of zinc carbonate is reacting with 2 moles of HNO3. Now how many moles of zinc carbonate is reacting in this reaction? 0.02. 0.02 is going to react to form how many moles of HNO3? So 0.02 times 2. So it will be 0.04 moles, right? So 0.04 moles of HNO3 is reacting. Okay, wonderful. Now next is calculate the concentration of HNO3. So if you have seen my concentration video, then let's calculate it. So concentration, the formula of concentration will be equals to mole per volume. So mole is how much mole we got? 0.04 mole of HNO3 divided by volume is 20 centimeter cube. So I can put 20, but here I have to represent it in decimeter cube because the final unit is in decimeter cube. So into 10 to the power minus 3. So let's put it in the calculator and find it out. So it will be equals to 2 mole per decimeter cube. So this is how we can solve the stoichiometric calculation. Thank you so much for watching. Now in the next video, we are going to solve all the past papers from 2018 to 2022. All the papers, mole concept question. Please follow the video. If you want one-to-one tuition classes or a batch tuition classes, please contact me. Follow the next screen. Thank you so much.